Hello, good morning, good afternoon to everyone. I'm Alessandro Gasso from Autodesk. So I'm an adoption specialist for generative design. I've been with Autodesk for the last 18 plus years. I'm based in Switzerland, and I was an Inventor user since release number 1. So the purpose of this presentation is to try to explain why you should consider a tool like generative design that is part of Fusion 360, even if Inventor remains your main design tool. So we are going to explain a little bit what is generative design, and we will also have a look to a workflow starting from Inventor, moving to Fusion 360 generative design, and then end it back to Inventor. With me today, I have my two colleagues, Apollo Vanderberg and Mike Fiedler, who will help me with the Q&A. So please feel free to type your question while I'm presenting. Mike and Apollo will answer to those questions. Then hopefully we will have also some time for Q&A at the end where we can answer to even more questions. So you can type your question, or if you prefer at the end of the session, you can raise your hand and we can unmute you if you prefer asking your question live. Okay, so why you should consider?
Alex,
Yes,
you're not sharing.
Oh,
can you share your screen?
Sorry. So
yeah,
sorry.
It's there.
Okay. So no worries. I'm not going to repeat all the introduction. So why you should consider generative design? We consider generative design a great revolution for the industry compared, and I will try and even more to the other revolution that I'm going to listen here, like the one when we moved the engineer from the drafting border to the 2D CAD, so that they could have their design in an electronic format. Then we moved to the 3D parametric design. That was also a huge step from the 2D. Then we could simulate our design. So simulate the behavior of our design without having the need, for instance, to producing a prototype. But actually, all those three great revolution basically are basically they are good for documenting ideas that we already have in mind that are based on our experience. Experience is great, but sometimes can be a barrier to the innovation. While generative design, the approach with the generative design is completely different. So we don't have a solution for the problem that we want to solve, but we need to be good in framing this problem. So providing to the software the information about what we want to design, the properties that the part that we want to design need to have, and let the software doing the CAD work. But the human role remains very critical, because we must be very good in framing the problem, because what we will get back from the software will be accurate if the way we have framed the problem is also accurate. And then we remain the brain in front of the screen. So we can make an educated decision, because we have all the possible solution to our problem in front of us. So to make another comparison, so this is the traditional approach, where we start with a few ideas, again based on what we have designed in the past. So we do a kind of back and forth for validating those ideas, for checking if we can produce those ideas, and then we produce those ideas, but probably we are going to produce something that is very similar to what we have produced in the past. Maybe we can use some simulation tool for making it lighter and so on, but basically the idea it's not very different. While the approach with generative design is that once we have framed the problem, the software will propose us again all the possible solution based on the information that we have provided. And those solutions are manufacturing aware, because one of the information that we need to provide to the software is how we are going to produce the part. And we can explore, for instance, in one study, different manufacturing type, different material, and then we can make the trade-off, having all the possible solution in front of us. Again, it is not the software that decide what is the best solution, because we know our needs, we know our budget, we know if one solution is good enough, so we don't need to spend more, and so on. But we will end up with solution that will have a better performance, will use less material, and solution that in most cases a team of human beings could not have conceived. So another advantage of using generative design is also the consolidation of the parts. So in this example from General Motors, this company, for instance, has replaced this 8 component with one single part that is 40% lighter and 20% stronger. But the real advantage beside that is that they could select the optimal solution out of 150 design options that generative design has proposed. So here we can see a little bit how generative design works. So basically, starting from the entire volume, start melting down the material where we have less stress, and adding material where we have more stress. And then this is all the solution that he could propose in this case, and the customer could do the trade-off, simulate an additive production in this case, and replace the 8 components of this part of an electrical car with just one part that was lighter and stronger, and they are doing this with many other parts for those starting from, of course, electrical cars. So probably if you have already seen some presentation related to generative design, you have seen for sure all those alien shapes. So what is the reality is that generative design is not for advanced additive manufacturing, but is also for more traditional way of production that you can see here, like the casting, the milling, and in conjunction, in conjunction also with the cost analysis that we can offer for our partnership with a company called A Priori. This make at the end the trade-off between all the possible solution to our problem much easier. So again, not specific for additive manufacturing, and I'm restating this because this is one of the main misconceptions around generative design. So let's start to see how this works. So we can select different manufacturing type. The frame is not available yet, but will arrive soon. So from the unrestricted that require an advanced additive manufacturing technology for producing it, but also to 2-axis, 2.5 axis, and then possibly the solution for the 2-axis is the cheapest and is good enough for what we need to do, and we can go further with that solution. So this is interesting because one of these three triple clamp of a motorcycle, just one of them was completely designed with generative design, and probably from the idea that most people have about generative design is the one that maybe less people can imagine, because it is the one in the middle, while the other where the first one was a mix of generative and human design, and the third one was a human design. So the second one is an example of a generative design outcome with a traditional manufacturing, for a traditional manufacturing production. And as I was saying, now for helping in basically doing the trade-off and select the part that we want produce out of all the possible solution. We have also the costing analysis because we have this partnership with this company called A Priori. So this is an example of a filtering option where we can select the cost. So again, so why you should consider, according to us, of course, generative design for improving the product performance, increase the productivity, because as I've shown, we reduce the time to market, reduce product costs, and I would add also for increasing the innovation capability of your company. So, as I was saying at the beginning, by no means this presentation is because we want to move you from Inventor to Fusion 360. But this presentation want to show you that, again, even if Inventor remains your main design tool, you can still leverage the capabilities and the advantages that I have just tried to present of generative design, because at the end of the presentation we are going to see this workflow moving from Inventor to Fusion 360 and then back to Inventor. So if you are if you use Inventor as part of the product design and manufacturing collection, the news is that Fusion 360 is also part of the product design and manufacturing collection. So you just need to be added from your contract manager or software coordinator. Basically, you just need to assign to you the use of Fusion 360, and you just need to install it and then basically use the same credential that you use for Inventor for logging in Fusion 360. So the use of Fusion 360 has a cost. So for instance, for doing a study, it costs 25 cloud credit. That is about 25 US dollars. But from a study, you can get an average of 100 outcomes. So 100 possible solution for your problem in less. I mean, the calculation, depending on the complexity of the project, can go from 30 minutes to 24 hours, no more, because after 24 hours there is a timeout, but this is another. So in 24 hours, you get 100 possible solutions to your problem, and then you can export one of these solutions with 100 cloud credit. I don't know if you consider this expensive or not, but if you think of a team of engineers working for getting 100 of possible solutions for a problem, I think this could cost more. And also, I mean, probably they could not conceive all the outcomes that generative design can produce. Okay, so let's have a look to how generative design works. This is really easy. So basically, so let's say if you want to design this component of this model cycle, so we need to define a preserved geometry, so the so-called key pins zone. So we are telling to the solver, okay, do whatever you want, but in the final outcomes, I need to have those regions as I have created them. And this is because, for instance, those regions, you need those regions for assembling the part that has been designed with generative design to the other components of your assembly. Then we need to define the obstacle geometry, so the keep out zone. So we are saying to the customer, you cannot create materials here because you need clearances for fastener, for accessing with the tools, but you have also other components, of course, of your assembly, and those components could move, and you need also to consider the clearance when those components move. So this marketing video, so this is not the real user interface that we are going to see more in details later, but show a little bit the concept that I'm trying to explain you now. So the green geometry are the preserved geometry, so what the key pins zone, so what we need to have in the final outcomes. The red zone where we cannot have material. Then we define the objectives for our study, the production method, and then we will end up with all those outcomes, and we will start filtering them out. So for narrowing down the number of solutions that we want to move further with. And based on different consideration, we do the trade-off, let's say cost of production, performances, and other consideration. We at the end we will end up with the part that we want to produce. In this case, is still an additive part. Actually, it's a little bit an hybrid approach with the finishing with subtracting finishing. But so this is just for clarifying a little bit what I'm trying to explain. But now let's have a look really to the workflow. So we are going to define the design space. So basically the entities that we are going to define as obstacle. So the red one as preserved geometries. The green one, and then you see here also you have the option. It's not mandatory, but in some cases it's recommended to use a starting shape, and is the entity that you see in yellow. Then we will generate a bunch of outcomes, and then we will do our trade-off. We will select a couple of outcomes. We will show how to modify them a bit, because probably one thing that I forgot to mention that is very important. The outcomes from generative design are a solid model that you can very easily modifying for doing a kind of fine-tuning for preparing them for the production. You can modify them in Fusion 360, but if you prefer, you can bring them back to Inventor. You can convert them to Inventor model, or you can use in Inventor a native Fusion 360 file. So that, but I'm going to show how you can modify those components in Inventor, and how you can also validate your modification before producing the real component. Okay, so we start in Inventor from this assembly. We want to design the gripper of this robotic arm. So in Inventor, in the Inventor assembly, I have created a representation that contain just basically the bodies that I need for creating the other entities for my design space. So for defining the preserved geometry and the obstacle. I've stopped the video because there is something that I want to show you that is very important. From Inventor, in Inventor, I'm going to create a new part in the context of this assembly. But I'm going to save this new part from Inventor. I can save this part directly on Fusion 360 in my project on Fusion 360. So I can do this directly from Inventor. So this is an Inventor file, but now is located on my Fusion 360 project. So I'm going to copy in the new part the bodies. that I need to move to Fusion 360 for doing the generative design setup, and I save the Inventor file, and I'll get the Inventor, the update in Fusion 360, and I can open the Inventor file. You see an IPT file. I can open this IPT file in Fusion 360 without converting anything. Okay, now moving forward. So, okay, now I have created this part in Fusion 360, but you can understand very well that I could have created this part in Inventor, and then, for instance, inside the new part that I have created, and then just saving the new part, I could have got this part in Fusion as those two parts. But so what I'm going to show you now, so this part has been created in Fusion 360, but I can create this part very well in Inventor. And also the next step that I'm going to do in Fusion can be done very well in Inventor. Of course, since in Fusion I'm in the generative design environment, so those simple extrusion and cut that I'm doing in Fusion 360 that can be done very easily in Inventor as well. I've done those in Fusion 360 in the generative design environment because, for instance, some of them get recognized automatically as obstacle. Then I define the additional obstacle. Then I define the yellow part as a starting shape and the green part as preserve geometry. Okay, so I have created my design space. Again, all those components that I have created in Fusion 360, I could have created them in Inventor, and then just saving the Inventor file, I get all those bodies in Fusion 360. So now, instead, what I'm going to show you now is really specific to the generative design environment inside Fusion 360. So now I'm going to define the design condition. So basically, I'm going to define the loads and the constraints. So I'm going to define the load configuration that basically represent the loads where the gripper, so the loads that will act on this gripper while the robotic arm is operating. Then I define the criteria. So in this case, I want to minimize the mass, and I set a factor of safety of 2.5. And now I'm going to communicate to generative design the manufacturing type that I want to explore. So I go from the unrestricted, advanced additive to 3-axis milling, 2.5, 2-axis. So I'm asking the solver to explore all those manufacturing types in conjunction with the different material that I also want to explore. In the same study, I can explore up to 7 material. Then I start a preview. The preview is very important because the preview, even if it's a rough preview, but is good enough for checking that I didn't forget, for instance, an important obstacle, and So the solver is going to adding material where I cannot have material. So it's recommended to do that before starting the generation that, as I said, cost 25 cloud credits. Something that I forgot to mention, we are also considering other, let's say, business model for using generative design, but so far this is how it works. Okay, so I start the generation of the outcomes if I'm happy with the preview, if the preview tells me that I didn't forget an obstacle and I'm going to get material where I cannot have it. And then so those are all the outcomes that the solver has created, and I start doing my trade-off using the filtering option that I have in generative design. And so I start narrowing down the few outcomes that could be interesting to produce. I can compare them, and then I'm going to export. So I'm going to export this outcome. This is an unrestricted outcome, so I can manufacture it with some advanced additive manufacturing technique. And I'm going to export instead an outcome for 2.5 axis, so more traditional manufacturing type. And as I'm going to show in a moment, I'm going to modify. So as I said, the outcome is a solid model. In this case, this is a unrestricted for additive production, so organic shape, and I can modify it if I need to do that for preparing it to the production with the test spline technology that is very similar to the Inventor freeform. While the more I can also modify if I need the 2.5 axis outcome, just editing the sketches. And then, as I was saying, I can bring back those components in Inventor and modify them there, even if in Fusion 360 we have some specific tool for doing that, like the test spline for the organic shape. But for instance, I have also the option in Fusion 360 to generate the toolpath for the outcome for the 2.5 axis, and then generate and export the relative G-code. But so I can simulate. Now, another interesting things, maybe I can stop for a moment. So you have seen that I have modified the outcome for the organic, for the additive production. And I want to validate the modification. So I want to be sure that what if I have changed has not compromised, for instance, the factor of safety. For doing this in Fusion 360, I just need to open the outcome and go to the simulation environment. And I have the option to inherit all the loads and the constraints that I have used for the generative design study. So I don't need to reapply them. So I can simulate this and verify that my modification didn't compromise for instance, the factor of safety. Notice that I can also export these to ANSYS for a more advanced analysis if I need it. So those are the results of the stress analysis, where I have used the same load and constraints of the generative design study. And then also in this case, as I said, this is going to be produced with an additive approach. In Fusion 360, I have the option also to simulate the toolpath for the additive production, as you can see here. Okay, so any option for doing that. And we get gently to the end of the story. So after that, I've simulated the toolpath for the additive production. And the end of the story, as I was saying at the beginning, is back to Inventor. So this is my 2.5 axis outcome that is in my Fusion 360 project, is a Fusion 360 file, but I can place it in my Inventor assembly, in the Inventor assembly, where I have start my workflow with a simple place component, but basically going in my Fusion 360 project directly from Inventor, and I insert the component. Now I can convert, as I was saying, I can convert this model to an Inventor file, but I mean, I prefer, for instance, use it as a native Fusion 360 file inside Inventor, so I can keep the associativity. So if I'm going to change something in the native file in Fusion 360, I can consume the update in Inventor, as it's basically as what we the other way around we have seen at the beginning, where I have created an Inventor file, and then I got basically, I could open this Inventor file in Fusion 360, and if I had modified the Inventor file, I could get the update in Fusion 360. So I insert then the native Fusion 360 file in my assembly in Inventor, and then with some constraints, I'm going to position the two parts of the gripper in the right position. So just something really basic for Inventor user, a couple of constraints. And this is the last one, and then the two parts of my gripper design in generative design are in the right place in Inventor. So where in this case part that can be produced with a traditional approach, 2.5 axis, but design with generative design, with so less material, with better performance. And so that was the end of the story. I hope it was not too long. So I don't know if we have a question that still need to be answered. think that Apollo and Mike have answered basically to all the question. But if you have additional question, you can type your question, or if you prefer, you can raise your hand and we can unmute you so you can ask your question live. Apollo, Mike, I don't know if you want to comment about the question we had and.
No, I mean, we had a couple good questions. You know, one was around whether the outcome produced from generative design was associative to the originating inventor part, and the outcome itself isn't originating. You know, if you modify the original inventor part, the outcome will not update as is. As you know, with the workflow that Ali showed, where you're leveraging that inventor part in Fusion, all the preserves and obstacle regions will be updated, but the outcomes are, if you will, a snapshot of when you've submitted that simulation. So all the outcomes would be based off of where they were when you submitted to get those generated.
Yeah, this is a good point, because this is also something that I would like to clarify. So the interoperability between Inventor and Fusion 360 works in the way that I can open a native file, an Inventor native file in Fusion 360, and if I update the Inventor file in Inventor, I get the update in Fusion 360. Or I can open a Fusion 360 native file in Inventor, and if I modify the Fusion 360 file in Fusion 360, I get the update in Inventor. So that's the way it works. So as Apollo said, the design space, so the preserved geometry and the obstacle come from Inventor model. So if I update those model, I'll get the update in Fusion 360. So the preserved geometry and the obstacle will update, but not the outcome. By the way, the outcome is a Fusion 360 file instead. So when I place the outcome in my Inventor assembly, if I change something in the outcome in Fusion 360, I'll get the update in Inventor. So. Okay, so this last question. So if you limit your machining option like only 2D, does that limit the possible number of solutions and in turn reduce the number of credit? The answer is no. Yes, it reduces the number of solutions, but each study is 25 cloud credits. It doesn't matter how many manufacturing option you are going to explore. But as I was saying, this is the current model. Unfortunately, I cannot disclose this at this time, but if you are interested, stay tuned, because probably in May there will be other option for using generative design in terms of payment, let's say. So, and based on the way you use generative design, you can basically choose the model that it's more convenient for you. But so far, that's the way it is. Thanks for the question. Any other question? Okay, not, I hope this was interesting. Thanks for your attention. This presentation will be recorded and available, I think, on the site. Okay. The loads can be already prepared on Inventor site. No, the answer is no, because it's basically the definition of the load cases. It's really specific to the generative design environment. Any other question? So as I was saying, the recording will be available on the site where you have registered for the session, right, Anton? I don't know if you...
Yeah, the recording will be available on the same website where you can register to the next one, and I will drop the link in literally 1 second.
Thank you. Okay, if there is no more question, again, thank you for joining the webinar. I hope this was interesting. Thanks for the question. If you have more questions in the upcoming days, please reach out. Alessandro.gasso@autodesk.com. And thanks again. And there is maybe one last question. Was this feature in Inventor 2017, but now? Not sure if I got the question, John. Maybe if you can elaborate, what feature are you referring to? The AnyCAD functionalities? At one point, no.
Yeah, there was a shape generator that was in Inventor, exactly, which still does exist, and we have a similar tool available within the Fusion simulation space. Generative design came from Project Dreamcatcher, which was an independent product, and then kind of debuted initially as an independent product before we merged the technology into Fusion.
Yes, thanks, Apollo. But that's interesting because, again, shape optimization, as I was saying at the very beginning of this presentation, with shape optimization, you should design your shape, and then shape optimization suggests where you can remove material, but you have already your shape in mind, so the shape is your conception. While generative design, you don't provide a shape, you ask to the solver to provide you more than one shapes based on the details, based on how you have framed the problem that you want to solve. So it's a different approach. Yeah, you're welcome. Okay, so thanks again, and hope to see you soon in one of the upcoming webinars. Thank you.